So welcome to the next video. So in this video, I am solving a previous year KTU problem which came for 6 marks in 2019 December. So remember this was asked in S3 MOS. This is from module 5. In module 5, it is from the column section. Okay. So this question is slightly similar to a question that is asked in GATE and all. So this is not exactly a numerical problem. This is some kind of derivation. Okay. So they are asking determine the ratio of buckling strength of two columns, one hollow and the other solid. Both are made of same material and have equal length. Okay, so there are two columns which is made of same material and material is same and the length is same. Cross section area and same end conditions. So boundary conditions, everything is same. The cross section area is same. Okay, internal. So one is hollow, the other is solid. So let's say one is hollow. I'll call this as A. Other is solid. I'll call this as B. Okay, this is the area. Now, what is given? It is the material has same, both have same material. So that means the both will have same E. The E will be based on material. So both will have same E. Then length is same. The length of the material is same. Both are same. Then the end condition is also same. So that means effective length is also same. Effective length depends upon end condition. Okay, it may be both are pinned, both are fixed, one is fixed, other is pinned. Whatever it is same for the both case. So since boundary conditions are same, since length are same, the effective length also will be same. Okay. Now they are also telling the cross section of this and cross section area of this is same. Okay. So now let's say we'll put some parameters into this. Let's say the outer diameter of this is capital D. So they are telling that internal diameter of the hollow column is half the external diameter. So external diameter is D. So internal diameter is half the external diameter. So that is, this is D by 2. So that is given in the problem. So this instead of D, I'll call this is DA and this is DA by 2. Okay. And diameter of this column I'll call as DB. DB, capital D, B. Now they want us to find what is the ratio of PA to PB. PA to PB. This is what they want us to find. Now what is PA, what is PB? We can directly write. So PA is given by, PA is pi square EI upon LE square. Now I will be different. E is same for both the columns, so I am using E. LE also same for both columns, so I am using LE here. Okay, so this I is I for the A, column A. Now PB is given as same formula. This formula is Euler's buckling formula. So student is expected to remember this E upon IB upon LE square. Now you remember, you observe this, in both equation I have used E, both equation I have used LE because both are same for the column. It is not different. Only I is different. Now we can see that the ratio of PA by PB, this comes out to be, so when you, so PA is pi square E IA upon LE square times, so 1 upon PB is nothing but LE square upon pi square E IB square. So this is nothing but ratio of, sorry, IB, ratio of moment of inertias. So it is nothing but IA to IB. Okay. So the ratio of Euler's buckling load is, for this condition, it is given as, it is equal to IA by IB. Now we just have to find IA and IB and we just have to write the solution. Okay. Now let's say we will calculate IA first. IA is a hollow circular cylinder, so it is nothing but pi by 4. Hollow circular cylinder, the IA is given as pi by 64 d to the power 4 minus small d to the power 4. So in this case, it is nothing but pi to the power 6, pi by 64 into dA to the power 4 minus dA by 2 to the power 4. Okay, so this comes out to be pi by 64 into, so dA to the power 4 minus dA to the power 4 divided by, so this is 2 to the power 4, so that is 2 to the power, this is 16. 60. Okay. Now this is nothing but pi by 64 dA to the power 4 into 1 minus 1 by 16. So this is nothing but pi by 64 times dA to the power 4 into 16 minus 1 is 15 by 60. Okay. So this is the value of IA. Similarly, I can calculate the value of IB. IB is solid, so it is pi by 64 into d to the power 4 is the general formula. So in this case, it is pi by 64 into dB to the power 4. This is IB. Okay. Now let us find the relation between dA and dB. So for that, what we have is, it is given that both column has same area. It is given in the problem that it has both same area. So you will use that. So area of the first column is pi by 4 into dA square minus dA by 2 whole square. This is the equation for area, right? So dA is the outer diameter square minus inner diameter square. So this will be equal to pi by 4 into dB square. Okay, now we can cancel out pi by 4. So this is nothing but dA square minus dA square by 4 equal to dB square. So this again gives me dA into 1 minus 1 by 4 equal to dB square. So this gives me, so this is dA square. Okay, so dA square, dA by dB square, or I will write 4 minus 1 is 3. 3 by 4 dA square equal to dB square. So this is a relation that we have. Okay, so we will see where we can use the relation. Okay, now we will come to the origin relation. Our IA by IB, IA we have here, IB we have here. Now what is IA by IB? Let's say IA upon IB equal to, so this is pi by 64 dA to the power 4 15 by 16 into 1 by IB is nothing but 64 upon pi, so inverse into dB raised to 4, right? So now we can calculate, cancel out some of the common factors. So this pi will go, 64 will go. So what we have is IA by IB will be equal to 15 by 16 into dA upon dB to the power 4. Okay, now can we use this? dA by dB up to the power 4 is what? So dA upon dB square is nothing but 4 by 3. So square of this will be dA by dB whole square. So this gives me, this value is 15 by 16 into, so square of this is 4 square, 4 by 3 square. Okay, so this is raised to 4, this is square. So square of this will give me dA by dB. This is nothing but 15 by 16 into 16 by 3 3 is 9. So this is nothing but 15 by 9 or 5 by 3. So this is the value of IA by IB. Now IA by IB is nothing but PA by PB. So this is also same as PA by PB. So PA is the ratio of hollow section to the ratio of the buckling strength of hollow section to buckling strength of solid section with the given conditions is nothing but 5 by 3. Okay, so I think this is clear. Now this is not a numerical problem, but the basic concept you have to use. And the only formula that we are using, which you have to remember, is the buckling formula and the moment of inertia of these two. Okay, so that's it. I think this is clear. Sorry for my bad handwriting. I hope you can read this out. Okay, thank you.